Welcome to time series analysis. In this module, you will learn about what time series is, how it's different from whatever we have seen so far, and why you should care about time series analysis in the first place. You will learn how to handle time series in pandas and specific data cleaning and EDA steps for time series data. Last but not the least, we will conclude with modeling, first using traditional ML techniques that you have seen so far, as well as Facebook Profit, a dedicated time series model. So, what is time series analysis? Time series data is just data with a temporal dimension to it. That is, it contains a column or an attribute or a field with date and time information in it. Hence, time series analysis is simply the statistical analysis of such time series data where meaningful and useful information is extracted from it. There are several time series tasks. The most popular one is forecasting, which we will cover in this module. So, what is the forecasting task? Well, given data from the past till the present, we predict the future. Simply put, the independent variable in this kind of problem formulation are all the feature values from the past till the present time step. And the dependent variable or the target is the same feature value but at a later future time step. Well, why should you care about time series analysis? If you care about the future, you're pretty much stuck with it. From the micro to the very macro, you find time series data everywhere. For example, if you're interested in knowing what a particular stock would cost 2 days from now so that you can decide to buy or sell it today, well, that's a time series forecasting task. Please note that if you're not careful, you will draw wrong conclusions with time series data. Consider the graph below. There are two variables that are plotted here. The first variable is the number of people who died by falling into a swimming pool, whereas the second variable is something completely unrelated, which is the number of films actor Nicolas Cage has acted in. But what does the graph tell us? That they are significantly correlated. So, what's going on here? There is an underlying factor, which is the passage of time, implicit in both of these time series. As you know, everything changes with time. So, what are otherwise completely uncorrelated time series end up looking like they are very correlated with one another simply because of the passage of time. This is what we call a spuriously correlated time series. Another complexity that you can find in time series is that a model that works really well for longer time horizons, maybe a decade or a year even, might not work really well for shorter time horizons, like a day or a month, and vice versa. So, these are some of the challenges that you need to be aware of when you're working with time series data. Well, how do you work with time series data? Say hello to Pandas. Pandas has a ton of cool functionality for working with time series data. In fact, the name Pandas is derived from panel data or longitudinal data. We also would like to introduce the passengers dataset, which we will be using for the rest of the module. There are 144 entries and there are two columns of data in this dataset, and they represent the monthly total of US airline passengers from 1949 to 1960. If you remember the info printout from last slide, you could see that the month column is of object type, which means each individual element is a string. There is really no problem with this, but this makes feature engineering quite difficult. For example, if you're interested in extracting specific properties like the year or the month, string slicing is quite inefficient and difficult and might even be next to impossible considering that you could have date and time in different formats in a particular column. Would it not be nice if we could have a data type that is tailor made for time series? Well, say hello to the datetime 64 data type, where each element of a column of datetime 64 is a timestamp object. A timestamp object is very similar to the datetime object that you would find in the datetime module in the Python standard library. So there are two common approaches to convert a column that contains datetime information to the datetime 64 data type. So in the first approach, you set the parse underscore dates parameter of your read underscore CSV function call to an appropriate value while loading the data into the data frame. And in the second approach, you use the pandas function to underscore datetime after the data is loaded into a data frame. The cell output below displays both the approaches, and it also shows that the resultant data frames are identical to one another. So there are three main outputs in this particular slide, which explores the timestamp object in greater detail. In the first output, you can see the object type of a pandas timestamp being printed. In the second output, we print three different timestamps where we can see additional details like hour, time, minutes, etc. Notice how default values for hours, minutes, and seconds are automatically filled in when we don't give information for them. And as you can imagine, it can hold a ton of detail. You can access a ton of information from these timestamps using attributes, which is covered in the third output. Even nuanced properties like which week of the year, the Roman calendar month name, how many days in that particular month, etc., are all accessible via tailor made attributes of the timestamp object. So, how can you set your datetime64 column to be the index of your data frame? Well, firstly, why do you want to do this? There are benefits to having a proper index. Indexes are immutable, they are pre-computed and cached under the hood, which makes indexing and slicing on the index to be faster than doing the same operations on the other columns of a data frame. A datetime index has all those benefits as well as benefits of having a datetime64 data type. For instance, you can quickly shift data up and down using the shift method, which we will see later when we are generating baselines. You can also quickly align data with other time series data frames during merge operations. You also have access to all the good time series properties like year, day, etc. that we saw earlier, which timestamp objects had. It can also quickly upsample and downsample data. As you can see in the output, what was previously a range index is now a datetime index, which is the month.